shapes. There's like squiggly, non-geometric shapes. There's like recognizable shapes, like rectangles and triangles. And then there are non-standard shapes, like just a general quadrilateral. It doesn't have, that's not necessarily a rectangle or a rhombus or anything like that. So we're going to get 3 different methods for dealing with those 3 different kinds of shapes. All right, so the first kind is if we have this little squiggly shape. And this is actually, my father-in-law was he read satellite images for the Army. And when he first started, he's retired now, but when he first started, basically they would give him a satellite image with a scale, and he would have put a clear plastic cover over it and actually calculate, to calculate the area of this. Maybe it's like troops or housing or bodies of water or something, that he'd need to know the area of it, the surface area. So he would take like a plastic sheet, put it over the picture, and calculate the area on the grid. And the way they did it was they outlined the shape. The way they did it, to be a little more accurate, is they outlined the shape going on, never ever crossing over the shape like this. So they always went on the outside. They never made sure that the shape was completely inside the boxes. Okay? Then, but they got as close to it as they could, staying inside my words off a little bit. Okay? Then they did it, and they counted up what the area was. So they just counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. So that was 63. Okay? Then they did the exact same thing, only this time they drew inside the shape. So they drew only the squares that they could get to without crossing the outside of the shape. Like that. Okay? And they counted those up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6. And then they averaged them. So that's 89, right? Divided by 2 is 44 and a half. So they would get 44 and a half, okay? Another way, the way that like computer programmers do it now, is they get as close to the shape as possible, going inside and outside, just trying to come up with as close a shape as they can, just inside and outside the boxes, like that. Can you see the difference? So you can cross over the shape in this way. Like that. Like that. And then so the computer models, because it can get a little more detailed, it does that and comes up with an answer. But back then, what they did, and the way we would do it, is they would take the outside image, the inside image, and average them to come up with an area of that shape. Okay? So when you have a squiggly figure, that's the way you would deal with it. You would draw and outline it, we call it inline it, and then take the average. Okay, does that make sense? Kind of straightforward, not too difficult. Okay, then if we have a standard figure, okay, like what does this figure look like? Okay, it looks like a rectangle. How can I make sure it is a rectangle?
Check all the sides are equal. No, like check all the sides are equal.
Okay, I think there's an easier way though than checking all these sides are equal.
90 degree perpendicular.
One of the angles could be a right angle. How would I check for that?
Slope.
What about the slope? What would happen if it's made a right angle? What would the slope do? They'd be opposite reciprocals. Right. If I found the slope of this leg and I found the slope of this side, and they would be opposite reciprocals of each other. So let's check that first and make sure that it's a rectangle. The thing that saves me is if I know it is a rectangle, then I only have to find the measurement of two sides. If I use the fact that all the opposite sides are equal, then I might as well not have bothered because I've already done all the work. So the thing that this saves me is I can tell it's a rectangle before I go to all the trouble of using the distance formula. So let me give you the points because this is 2, 4. So I know they're hard to see from the back. This is 4, 0. This is -2, -3. And this is -4, 1. All right. So check on the slope. Tell me if it's a rectangle or not. So it's at that point that I want to calculate the area. So plug it in the calculator. All right, so I do 2 square roots of 45 plus 2 square roots of 20, and that gives me 6. Oh, I did it of 2. Darn it. Did I do it? Yeah. So 2 square roots of 45 plus 2 square roots of 20. That's better. So I get my perimeter is 22.36. Okay? My area, how do I find area? Base times height. Square root of 45 times square root of 20. Which is a square root of 900, which is a nice even perfect square. What's the square root of 900? 30. Right. Okay? All right, so we got squiggly area. We've got a perfect area, like a rectangle. What if it falls somewhere in between? What if it's got straight sides, but it's not a shape that we know how to calculate the area of? Any ideas? What would I do there?
Find the height and say.
Well, these two are, it's not a shape, like it's not a trapezoid, it's not anything that we know for sure.
So do we do half to diagonal?
Nope. No? Well, I guess we could. I think there's a way easier way. We can use a distance, but then we wouldn't be able to find the area because we could do the perimeter that way, but then we couldn't find the area.
So you just take like the points like 2 times and plug it in and
Okay, we could do that. Right, and then divide it into 2 triangles and then find the height and calculate the distance of the height. Okay. I think there's an even easier way. That would work. Along with, we'd also have to use the distance formula to calculate the area of all the sides for perimeter. Any ideas? Oh, come on, you have 2 class got it? Well, they're slanted, so we can't just count. But that's kind of the idea. It's just counting. What if I put it in a box, a rectangle? I made it into a rectangle and turned it into a shaded area problem. Took away these pieces and just left that, right? So for area, I would find the area of the rectangle, subtract out all the triangles. What kind of triangles are all those? Right, our favorite, our best friend, right triangles. And in a right triangle, the height and the width are always what? Where do I find the height and the width in a right triangle? The legs. The legs. So the legs are horizontal and vertical. So I can just count, right? So first let's find the area of the rectangle. So that's 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7 by 7. So the area of the whole rectangle is 56, right? Now I got to start subtracting out triangles. Okay, this triangle is 1, 2, 3, 4, 5 by 3, 4. So 4 by 5. So 1/2 base times height is what? 7. I'm going to subtract 10 for that shaded area. This is 1, 2, 3 by 1, 2. So 1/2 by 2 by 3 is 3. This is, let's see, 1, 2, 3, 4, 5 by 1, 2. So 1/2 by 2 by 5, which is 5. And this is 1, 2, 3, and 1, 2, 3, 4, 5, 6. 3 by 6, so 1/2 by 3 by 6, which is 9. Add those all up, I get 27. 56 minus 27 is 29. So the area of my shape in here is 29. Okay? Now, I could do the distance formula to find the perimeter, but since I already have white triangles, what other thing is that available to me? The Pythagorean theorem, right? And this is, do I have any triples? This is 3 and 2. This is 5 and 2. Do I have any Pythagorean triples before I start? 1, 3, no, I don't think I do. No. All right, but I can still do Pythagorean theorem. So 4 squared plus 5 squared equals c squared. So 16 plus 25, 41? Yep. So to get the square root of 41 is that one. 9 plus 4 is 13, so I get the square root of 13 for that one. 25 plus 4 is 29, so I get the square root of 29 for that one. And 9 plus 36 is 45, so I get square root of 45 for that one. And then I just plug all those in. Square root of 45 plus, don't forget to put your end parentheses on, otherwise it's going to mess up. Square root of 41 plus square root of 13 plus square root plus square root of the last one, 29. That gives me 22.1. So my perimeter is 22.1. All right, so those are the, oops,